Hello everyone. In this video we're going to be solving an interesting rational equation. We have x squared plus 4x squared divided by 5x plus 2 quantity squared equals 5/9, and we're going to be finding the x values. This problem is similar to a problem we have done on September 13th. I'll try to share the link down below. So first method, I'll be presenting two methods. My first method is basically make a common denominator, expand everything, do the work, and come up with a quartic equation. And this is what the equation looks like. To keep a long story short, if you do all of that, you're going to get 225x to the fourth power plus 180x to the third power minus 53x to the second power minus 100x minus 20 equals 0. This is a quartic equation. Good luck solving that. But this equation has two real solutions. Of course, x should not equal -2/5. That is going to be our vertical asymptote. When we take a look at the graph at the end, you're going to notice that there's a vertical asymptote. Great. So what are the roots? If you solve this equation by using whatever means, you're going to end up with the following solutions. Thanks to Wolfram Alpha, this is what the solutions look like. I already told you there are two real solutions and two non-real complex solutions, as you can see here. Great. So beautiful, right? Obviously. Okay, so that's basically the first method. It is brute forcey. It's very long, but I just wanted to keep it short for you guys because that's a lot of work and we don't need to go into that. So let's go ahead and take a look at a different approach, and at the end we're going to be looking at the graph. Okay, great. So second method. So first method was brute force. We made a common denominator and we ended up with a quartic. Obviously, for these kinds of equations that usually appear in math Olympiads or competitions, there's usually a quicker way to do it. There's a trick. There's almost always a trick with these problems. That's why they ask these questions, because you have to sometimes do them in a short amount of time. Anyways, so this is the original problem, and guess what? Substitution is really, really cool, don't you think? Okay, so we're going to use substitution for that purpose. And it's one of my favorite methods. So I'm going to go ahead and call this guy over here y. So based on that, I can write this as y equals 2x over 5x plus 2. Now this is really nice because it kind of turns it into, yes, it introduces a second variable, but it's going to turn into an easier situation. All right, so let's go ahead and work it out. Now, in the previous problem that we've done a while ago, substitution was much more straightforward, but this time it's a little tricky. So here's how we proceed. First of all, I noticed that I can't divide the numerator by the denominator, but if I reverse the process, kind of like flip the fraction, things are going to be a little easier because I can separate them. So I can't split as is, but I can if I take the reciprocals. So let's go ahead and do that. Take the reciprocals. This is going to allow you to separate it into 5x over 2x plus 2 over 2x. And obviously we have 1 over y on the left hand side, and the right hand side can be simplified because x is going to cancel out. Obviously we know that x does not equal 0 because x equals 0 will make the left hand side equal to 0. Remember the original equation? It's not a solution. Great, so we can do that, and 2 cancels out, and that leaves us with something super duper nice. So we get 1 over y equals 5/2 plus 1 over x. Why is this super duper awesome? Because we can go ahead and put the x and y on the same side, and that's going to give us a, not symmetrical, but it's a good equation. And along with the other equation that we got by way of substitution, we got x squared plus y squared equals 5/9. So now we got this awesome system, right? Two variables, but this system is very, very easy to solve. So let me go ahead and introduce how we can solve this. At the end, we're going to look at the graph. So first of all, I want to make a common denominator here, right? This says x minus y over xy equals 5/2. And the second equation is just going to stay as is, but I can do the following. Actually, it's not going to stay. I can write the x squared plus y squared as x minus y squared plus 2xy. And this is equal to 5/9. Now notice that I have two variables. x minus y, and xy. Those are going to be my new variables. If you want, you can call them something, but here's what I'm going to do. Since we have this ratio here, x minus y over xy is equal to 5/2, I'm going to do the following. I'm going to call this 5k, and I'm going to call this 2k, because 5k divided by 2k, as long as k does not equal 0, is always 5/2. Make sense? And this is good because I can go ahead and substitute here. If I replace x minus y with 5k, that gives me 25k squared. If I replace xy with 2k, multiply by 2, that's going to give me 4k, equals 5/9. And then you can go ahead and multiply both sides by 9. That's going to give you 225k squared plus 36k equals 5. But if you subtract 5, you're going to get the quadratic equation. An awesome quadratic equation with real root guaranteed, because a and c have the different signs. But anyways, if you solve this equation, easy to solve, you're going to get k equals -6 plus minus the square root of 161 divided by 75. Beautiful, right? Okay, what do I do with this? Well, since I know k, I can find x minus y, I can find xy, and then I can just go ahead and substitute. So here's what I can do to solve this system. You can just isolate x, write it as y plus 5k, and then in the equation xy equals 2k, you can replace x with y plus 5k. Now notice that the value of k is known. This gives you a quadratic equation in y. Since you know k, you can solve for y, and then you can solve for x, because you can just substitute, right? Easy, yes, easy, but the solutions are not pleasant looking. Anyways, so if you do all the process, so let me kind of simplify this a little bit, show you a little bit. So y squared plus 5ky minus 2k equals 0, and that's what k is. Now, which value of k are we going to use, right? The answer is depends, right? Are they positive? Are they negative? So if you look at this expression right here, x and y can take both values, right? So you should be able to use both values. But again, like if you're trying to solve from here, y would be negative b plus minus the square root of b squared minus 4ac. That would be minus plus 8k all over 2. And then good luck substituting that into this equation. So in one sense, the second method seems a little easier, but the k value is not very nice. So let's go ahead and take a look at the graph. And those are going to be the solutions that you're getting. So we kind of have like a rational function that kind of looks like a parabola. Notice that y values cannot be negative. That's why it's always above the x-axis. And the horizontal line intersects the graph at 2 points, A and B. And those points are basically the solutions for x. The x coordinates would be the solutions. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.